Look up at the night sky. Take a moment to let your eyes adjust to the darkness. Thousands of stars pepper the darkness, each a distant sun. They seem eternal, unchanging, like tiny beacons of light that have always been there and always will be. But what if I told you that every star you see, from the brightest to the faintest, has a beginning, a life and an end? Each one is on a unique journey through the cosmos. The story of a star's birth is a tale of cosmic drama playing out over millions of years across vast distances. It's a process that involves the delicate dance of gravity and the chaotic swirl of gas and dust. It's a story of gravity, dust, and gas, culminating in the fiery birth of a new sun. These elements come together in a spectacular display of nature's power and beauty, and it's a story that continues to unfold every moment in countless corners of our universe. New stars are being born even as we speak, adding to the ever-expanding tapestry of the cosmos. Join me as we journey into the heart of stellar nurseries, where stars ignite and illuminate the cosmos. These regions are the cradles of creation, where the magic of star formation happens. Prepare to have your mind blown by the sheer scale and wonder of these celestial events. The universe is a vast and awe-inspiring place, full of mysteries waiting to be uncovered. We'll uncover the science behind a star's birth and reveal some surprising truths about these dazzling objects. From the initial collapse of a gas cloud to the ignition of nuclear fusion, every step is a marvel of physics. Our exploration will take us beyond the familiar twinkle of starlight to reveal the hidden forces and processes that drive star formation. We'll delve into the intricate mechanisms that govern the life cycle of stars. Get ready for a cosmic adventure. Together we'll explore the wonders of the universe and gain a deeper understanding of the stars that light up our night sky. Stars don't just appear out of thin air. They're born in vast, cold clouds of gas and dust scattered throughout galaxies. These clouds, called nebulae, are like cosmic fingerprints, each unique in its shape and composition. Nebulae are mostly hydrogen, the simplest and most abundant element in the universe. They also contain small amounts of other elements like helium, oxygen, and carbon. These elements are the building blocks of stars, the raw materials from which new suns will emerge. But what transforms these diffuse clouds into brilliant stars? The answer lies in a fundamental force of nature, gravity. Gravity is the architect of the universe, the invisible hand that shapes galaxies and guides the motion of planets. It's also the driving force behind star formation. Within a nebula, gravity acts like a cosmic sculptor. It pulls the gas and dust particles towards each other. As these particles clump together, the cloud's density increases and gravity grows stronger. This process of gravitational collapse can take millions of years. As the cloud collapses, it begins to spin faster and faster, like a figure skater pulling their arms in. The spinning motion flattens the cloud into a disk with a dense, hot core at its center. This core, called a protostar, is the embryonic stage of a star. It's still not a true star, but it's well on its way. As gravity continues to pull in more material, the protostar's core gets hotter and denser. Deep inside the protostar's core, the temperature and pressure become unimaginable. Hydrogen atoms, forced together by immense pressure, begin to fuse. This process, called nuclear fusion, is the engine that powers all stars. During nuclear fusion, hydrogen atoms combine to form helium, releasing an enormous amount of energy in the process. This energy radiates outward from the star's core, counteracting the inward pull of gravity. A delicate balance is struck. The outward pressure from fusion balances the inward pull of gravity. The moment nuclear fusion ignites in the core, the protostar officially becomes a star. It begins to shine brightly, emitting light and heat across vast distances. Our Sun, a typical star, has been fusing hydrogen into helium for about 4.6 billion years. Section 5. Stellar Diversity. A universe of different suns. Not all stars are created equal. The size, mass, and temperature of a star determine its color, brightness, and lifespan. Our Sun is a yellow dwarf, a relatively small and cool star. Other stars, like red giants, are much larger and cooler, while blue supergiants are extremely massive and hot. The mass of a star is the most important factor determining its fate. Massive stars burn brightly and die young, while smaller stars, like our Sun, live much longer lives. This diversity of stellar types enriches the universe, creating a tapestry of light and color across the cosmos. Section 6. The stellar clock: how long a star lives. It's not forever. A star's life is a constant battle against gravity. From the moment it is born, gravity tries to pull it inward, while the energy from nuclear fusion pushes outward. The outward pressure from nuclear fusion in its core prevents it from collapsing under its own weight. This delicate balance is what keeps a star shining brightly for millions or even billions of years. But stars don't have an infinite supply of fuel. Over time, they consume the hydrogen in their cores, which is the primary fuel for nuclear fusion. As a star ages, it gradually uses up the hydrogen in its core. This process can take billions of years for stars like our Sun, but it happens much faster for more massive stars. Eventually, the core runs out of hydrogen and fusion slows down. Without the energy from fusion, the star can no longer support itself against gravity. Without the outward pressure of fusion, gravity takes over, and the star's core begins to collapse. This collapse is a dramatic and often violent process. This collapse triggers a series of events that depend on the star's mass. The fate of the star is determined by how much mass it has left. Smaller stars like our Sun will expand into red giants, shedding their outer layers into space. This process creates beautiful nebulae that can be seen across the galaxy. Their cores will eventually cool and shrink, forming white dwarfs. These remnants can shine for billions of years, slowly fading away. More massive stars will experience much more violent deaths, exploding as supernovae and leaving behind neutron stars or black holes. These events are some of the most powerful in the universe, releasing incredible amounts of energy and creating heavy elements that are essential for life. Section 7. Beyond visible light: unseen secrets of star birth. Our eyes can only see a small portion of the electromagnetic spectrum, the range of radiation that includes visible light. But stars emit radiation across the entire electromagnetic spectrum, from radio waves to gamma rays. By observing star-forming regions in infrared, ultraviolet, and X-ray light, astronomers can peer through the obscuring dust and gas to study the early stages of star formation. These observations reveal details about the structure and evolution of protostellar disks and jets, providing valuable insights into the birth of stars. Section 8. When stars collide: stellar fireworks and cosmic alchemy. While stars may seem like solitary objects scattered across the vastness of space, stellar collisions do occur, especially in densely populated regions like globular clusters. When stars collide, the results are spectacular. The immense forces involved can trigger intense bursts of star formation, creating new generations of stars. Collisions can also rip apart existing stars, scattering their enriched material into space. These stellar collisions play a crucial role in cosmic alchemy, the process by which heavier elements are created in the universe. During a star's life and death, nuclear reactions in its core forge heavier elements like carbon, oxygen, and iron. Stellar collisions and supernova explosions disperse these elements into space, seeding the interstellar medium with the building blocks for planets and life. Section 9. The building blocks of life: Stardust and You. The next time you look up at the stars, remember this: the elements that make up your body, the air you breathe, and the earth beneath your feet were all forged in the hearts of stars. The carbon in your DNA, the oxygen you breathe, the calcium in your bones, all these elements were created billions of years ago inside stars that lived and died long before our sun was born. We are literally made of stardust, connected to the cosmos in a profound and intimate way. Section 10. A final thought: our place in the cosmic ballet. The birth, life, and death of stars are not just distant cosmic events, they are the very essence of the universe's grand design, playing out over billions of years. They are intimately connected to our own existence. Every atom in our bodies was forged in the heart of a star, linking us to the cosmos in a profound way. Stars are the cosmic engines that create the elements essential for life, from the carbon in our cells to the oxygen we breathe. And their deaths, often in spectacular supernovae, enrich the universe with the building blocks for new generations of stars and planets, continuing the cycle of creation. As we continue to explore the universe, we gain a deeper appreciation for the intricate processes that govern star formation. Each discovery brings us closer to understanding our place in this vast cosmic ballet. We are reminded that we are part of something vast and ancient, a story written in the stars that stretches back to the dawn of time. A cosmic story that began billions of years ago with the Big Bang and continues to unfold today in every corner of the universe, from the smallest particles to the largest galaxies. The next time you look up at a star-filled sky, take a moment to contemplate the incredible journey those stars have taken, spanning eons and light years. From their humble beginnings in interstellar clouds where gravity pulls together gas and dust to ignite nuclear fusion, to their fiery deaths that seed the universe with the ingredients for life, scattering elements far and wide. Our own existence is a testament to the power and beauty of these celestial processes. We are, quite literally, made of star stuff, a part of the universe's ongoing story.